Sand filtration is a process in which the treatment of the water is realized by the porous nature of a sand layer which traps particles present in water. Various other physical or biological processes also take place in the sand filter which further strip the water of different substances such as deferrization, demanganization, and ammonium removal. There are three main types: rapid gravity sand filters, upward flow sand filters, and slow sand filters. All three methods are used extensively in the water industry throughout the world. Sand filters can, apart from being used in water treatment plants, be used for water purification in singular households, as they use materials which are available for most people. Sand filtration is frequently used in the treatment of groundwater to remove dissolved iron and manganese in the groundwater are oxidized by aeration.
First documented use of sand filters to purify the water supply dates to 1804, when the owner of Bachelor in Paisley, Scotland, John Gibb, installed an experimental filter, selling his unwanted supplies to the public. This method then used by an engineer, James Simpson, for the Chelsea Waterworks Company to filter municipal water in London in 1829. Soon became mainstream as John Snow established the link between drinking water from contaminated well and cholera outbreak in 1854. In 1885, it shows that sand filters are capable to remove bacteria as the slow sand filters saved the cholera outbreak occurred in Hamburg, Altona in 1892. Sand filters were first developed in the 1890s and widely used in large municipal water systems in 1920s because they are required smaller land areas compared to slow sand filters. The first modern rapid sand filtration plant was designed and built by George W. Fuller in Little Falls, New Jersey, that were used in 1920s.
Slow sand filter. Do you ever wonder how it works? Firstly, contaminated fresh water flows into the enclosed system. Then, water flows over sand layer that removes sediments and solid from raw water. When water flows into the system, microbial layer, known as mud sticky, is created. The bacteria inside helps to feed on waterborne microbes passing through the filter. A constant rate of water is needed to maintain the layer. Water then flows through supporting gravel, which support the upper layer of the system. After the water passes through the gravel, clean water will flow to a pipe where it is stored or being used. The next part is, we will learn how rapid sand filter works. Rapid sand filter is another type of water filter which operating at higher rate about 25 to 50 times faster than slow sand filter. The first step is water flows inside the system through opening called inlet valve. Then it will flow to wash water trough, which is placed above the filter media that will collect the backwash water and carry it to the drainage system. After the wash water influent is distributed over the media bed, gravity pulls it through the filter at a rate of 1 to 2 gallons per minute per square feet. It is then collected by the outlet valve and distributed to storage tank for the chlorination or pump station.
Advantage of rapid sand filtration. First, a flow of between 4 until 21 m/h can be expected from a rapid sand filter, which is somewhere between 20 and 50 times faster than the range of slow sand filtration. Rapid sand filters are made using graded sand, sometimes with an additional crosses layer of material on top of the sand to increase the flow rate, for example anthracite, in which case they become known as dual media filters. Pre-treatment is usually necessary for rapid sand filtration. Such treatment could include coagulation and flocculation, followed by sedimentation. Cleaning time, backwashing only takes several minutes and filters can be put back into operation instantly. Disadvantage of the rapid sand filtration. First, high capital and operation costs, which may be increased further if there is a need for pre-treatment of the raw water. Skill supervision essential, for example, for flow control and dosage of disinfectant. Not effective in removing bacteria, virus, fluoride, arsenic, cell odor, and organic matter. Requires pre and post treatment. Requires greater maintenance than a slow sand filter and generally requires mechanical pumping of water, at least for backwashing. Advantage of slow sand filtration. First, no pre-treatment is usually necessary for raw waters with turbidity of less than 50 nephelometric turbidity unit. Coagulation and flocculation are not appropriate pre-treatments for slow sand filters because floc carryover is possible, which rapidly blocks the sand bed. Very effective removal of bacteria, virus, protozoa, turbidity, and heavy metals in contaminated fresh water. Easy to install in rural, semi-urban, and remote areas. Construction, operation, and maintenance only require basic skills and knowledge and minimal effort. Disadvantage of slow sand filtration. First, cold temperature lower the efficiency of the process due to a decrease in biological activity. Loss of productivity during the relatively long filter skimming and repairing periods. Natural organic matter and other disinfection by product precursors not removed may be found if chlorine is applied for final disinfection. Requirement of a large land area, large quantities of filter media, and manual labor for cleaning, low filtration rate.
As conclusion, sand filters can be a great pre-filter for ultrafiltration modules and systems since it filtrates very accurate. A sand filter is not used to remove bacteria and viruses. Therefore, an ultrafilter should be installed downstream the sand filter.